So, hi everybody. My name's Will, and hopefully you're here to learn about Protractor and checking angles and angulars with them, which we're going to do both of. So, a little about me for those who haven't met me before. I like to play. So I play dodgeball, and I like to play video games. I'm also a big fan of Disney, so if you want to talk about any of those things with me, I will talk your ear off. I like Minnesota. This is a great place to live, great place for families. We have great schools. Our weather is nice sometimes, a lot of the time actually. Even in the winter, it can be cozy. And we have a really great tech community. So this is the logo for our local Angular meetup group, which I help co-organize. And we have a lot of fun every month. We meet on the first Wednesday, so check us out on meetup.com. And I like to write code, and I like to write it standing up. I just got my standing desk at home, and I'm really excited about that. It's not quite to the level of this gentleman here, where he's got the hamster wheel, but I did get like a little standing elliptical thing, and I'm excited to use that. I've been doing full stack development for about 5 years now, and Angular for around 2. I'm really open-minded to trying new technology, but I like to fall back on what I know when I need to get stuff done. So enough about me. You're not here to listen to me. Let's talk about end-to-end testing. And let's talk about what Protractor does, which is end-to-end testing. Well, what is that anyway? Different people will define it different ways. So I'm going to go over really briefly what I mean by it. And in case that 2 throws you off, I'm not talking about E-Z-E. This is not the movie Straight Outta Compton. I'm sure you weren't confused about that, but I thought someone would guffaw at that, so hooray for me. No, we're talking about E2E, end-to-end testing. This is simulating what the browser will do when a user comes to our website with all the integrations, with a little asterisk on all the integrations that we'll talk about later. But there are some things you can do to mock away some integrations. So before we talk about how to do this, let's talk a little bit first about why we need to do it. It's important to do, and not a lot of us do it. And we have unit tests, and we think we're cool with that. We all write unit tests, right? Who writes unit tests? All right. So why do we need more tests? We have all these unit tests that we're maintaining, right? Well, you probably want to test what your users are going to see. At the end of the day, we're writing software that people are supposed to use. And we can write unit tests that test our code until our fingers break, but those are really for us. It would be great to have some tests that demonstrate what a user is going to do with our website. But there's a lot of other great reasons to learn about end-to-end testing. You can smoke test builds. This is something that I would have loved to have a couple years ago when I would be asked to kick off builds for a QA or stage environment, and then be asked to manually check and make sure that basic stuff was working with the website. Something like this saves a ton of time out of that to just run a little smoke test that says, here, the website is doing basically what it's supposed to do. We're ready to move forward. For those unfamiliar with the term smoke testing, it's kind of funny. It's a term used to describe making sure that software doesn't catch things on fire, like literally on fire. It's also used in mechanical engineering, like this picture, which I didn't know before, but it kind of tests like plumbing to make sure there aren't any leaks. It's kind of similar, but interesting. Automate boring stuff, like Jim over here recommended to me earlier. I do my time tracking every week, and I enter the same thing every time. So even if I don't need to write a test for my time tracking software, I could just automate the fact that I'm putting in the same thing every week. That would be awesome. Why wouldn't I use Protractor? But most importantly, I want to touch on the fact that this is super helpful when you want to continuously deliver. And by continuous deliver, I mean deploying code whenever you check it in. Now that might sound crazy to some people, but it's what a lot of big companies are doing now. And it really improves your competitive advantage in the market. You can get to market so much faster if you can write something, feel great about the fact that it's going to work, and ship it and get it in front of users. It also makes ops people happy because then they don't get as many pages in the middle of the night. And I've worn a pager and gotten pages in the middle of the night, and it sucks. And the tests are written in JavaScript for Protractor, so they're even pretty easy for a JavaScript developer to write. Now, I don't want you to get the idea that this is some magic solution. You may be thinking to yourself, oh my God, why am I not doing this already? It sounds great. Well, there are some downsides to this as well that people who have tried to write end-to-end tests have probably experienced before. There's two in particular that I'd like to call out because they're often the ones that give people trouble. One is that they're slow. You have to spin up a browser and click on things like a user would, and computers can do it faster. But compared to just running small bits of code for like a unit test, this is like snail on a turtle's back, slow, squared, slow. The other thing that often trips up Protractor tests is that they're brittle, like peanut brittle. Many of the reasons that a test might fail wouldn't conceptually break our understanding of what the user is trying to test. The test runs what we write, not what we wanted it to run, kind of like Venkat said this morning. Just like we make mistakes writing our code, we can make mistakes writing our tests. And things change over time, which means that we have to maintain our tests. And sometimes when you're testing all the things together, you are much more likely to have a little thing break, depending on how you wrote the test. We do have some means of mitigating this, though. We can isolate a small number of tests, like say 5 or 10, that really get at the core of what is it we want to make sure is still working. And you can take care to test only those things after they've become somewhat stable. So this is a place where I wouldn't really recommend dogmatic TDD, where I write a test and then I write my website to make sure that it works. That's not really what end-to-end testing is great at, because you'll often write the test not knowing exactly what it is your site needs to do, and then writing a lot of test code as you're writing your lots of code to make the website work. If you had a really hardened prototype that you'd put through a lot of user testing, you could potentially get away with doing test-driven end-to-end testing, and it might prove useful to you, but I can't say I've seen that where it would be really profitable. Now, how do you only choose the 5 to 10 core things that you're going to test? This is actually just a good exercise in general to define what it is your software is useful for. What do people want to do with it, and what do you really want to have happen when they use it? So, for example, we could take Twitter. What does Twitter do? You post tweets, and you follow people and listen to their tweets, and you should be able to follow new users and then start to see their tweets. And from Twitter's perspective, they want to show ads because that's how they make money. So if you had tests to cover those 4 basic things, and you didn't test really heavily stuff like direct messaging or profile settings or user lists, it might not be such a big a deal, because you can test those things other ways, or have tests that you don't always run to test those things and get a core amount of stuff that really gives you confidence in the fact that I didn't just screw up what my business is supposed to do with this software. So how do we accomplish this with Protractor? We're here to talk about Protractor. How do we do this cool thing called end-to-end testing? There's just a few key pieces really to keep track of, and this link on the slides links to the Protractor homepage, where it goes over all of these things in really nice detail. So first, you have to install Protractor. It's on NPM. You probably want to install it globally if you're planning to do this a reasonable amount, but you can install it just to your project, which can be good for CI. We can talk about that in a little bit. You need a spec or a specification of what we're going to test, how the page should behave. And this is, by default, a Jasmine test with the usual Jasmine things. So for people who aren't familiar, there's a describe saying, what is it I'm trying to test? An it to say, what is it should do? And some expectations, like expect something to be something else. Hopefully the same thing. There's also Protractor bits to this. So we can see on the 5th or so line this element selector, and you say by dot something, like model or CSS or repeater, and give it some string to identify what it is on the page you want to interact with. And you can send keys like typing out the contents of a to-do, or clicking on a button, or selecting some list of repeaters and asserting its size. You can use Mocha and Chai, you can use Cucumber. There's a lot of options. This is just what's there by default. A page object describing interesting elements. So on that last slide, we showed just sticking a bunch of element selectors in our specification. Well, it's really great to have a representation of what elements on the page you're interested in, separated from what those elements are supposed to do. It makes your test less brittle. It discourages random checking of elements all over the place. And it keeps your code pretty dry, so you don't have the same complex element selectors all over the place. You just have one way to say this conceptual button or this conceptual image on my page. And you need a configuration file to tell Protractor how to run. And these can be as simple as just having a specs list of what specifications you want to run. You can add a Selenium address to separate your Selenium runner from the executing Protractor tests. There's tons of options here. Be sure to read the docs. There's stuff like which browsers you want to run with, preparation functions, all kinds of stuff. But that's it. Like if you go to the Protractor website and follow those 4 or 5 files worth of steps, you can run tests against the basic Angular to-do site in like 5 minutes. It's pretty awesome. If you really want to try this right now, mind the conference Wi-Fi. It's been really good for NPM installs in general, but you might not have some luck. So now that we know what we need to do to get started, let's write some actual tests. And I'm going to start with sites without Angular. And yes, this throws people off at first, but Protractor is not just for Angular. You can write tests against any deployed combination of JavaScript, CSS, and HTML, and potentially get a good set of tests out of it. There obviously are things that make it better for testing Angular, some of that stuff like by model and by repeater. Those obviously aren't things on regular websites. Those are Angular things. But if you are used to writing JavaScript and want to write end-to-end tests, Protractor could be a great option for testing your site built with whatever, Ember, React, jQuery, plain old JavaScript. There's a little bit of setup to do. In your configuration, you're going to want to add an onPrepare function that adds this handy little function for this browser.ignore synchronization flag. And what that does is Protractor by default is going to wait when the page loads for Angular to finish booting up. And if you don't do this, then Protractor will assume you're testing an Angular site, wait around for 30 seconds, and then fail your test to say, sorry, I never got Angular. Little tricky thing to find. This is actually in a different set of slides on Protractor that's much better than mine by a guy named Ramon Victor, and I highly recommend checking out that slide deck. I have a link to it at the end. But if you don't do this, then testing a non-Angular site will fail. So be sure to at least add the browser ignore synchronization bit. So how do you selector? Like we had this by model and by repeater. How did I get things in that test that I would have been able to test a non-Angular site with? A lot of examples are going to use those specific Angular things that you go looking for on the web. But remember that we had by CSS. So you can get your jQuery on here a little bit. If you're used to or remember doing jQuery still, the same types of selectors you'd pass to jQuery, you can pass to this by CSS. So like this div pound logo, so the div of ID logo, child div after that, the first child of an A tag. That's an image that I'm grabbing out of one of the tests we're going to see in a second. Do note that these, like jQuery selectors, can get busted easily. You can have a designer on a team changing up CSS and HTML and making it more semantic and actually better. But to them, they might not know that we have these kinds of tests, and without feeling like they really did anything wrong, in fact, maybe feeling like they did something great to clean it up, they may have inadvertently broken a bunch of these selectors, and then you have to go and update your tests. Keep an eye on that kind of stuff. This approach is a little bit hard to maintain, and if people have better ways of doing this, I'd love to hear about it. But this is the best way I could find that people who are testing non-Angular things kind of did. So let's see this in action with the conference website. That's what I chose to do as a non-Angular test. So here's the conference website. If I'm the conference website organizer, what kinds of things would I want to test about this? Well, I want to make sure the logo's on there and that it's big. And I want to make sure the Twitter link is on there because I care about Twitter. And for me, writing these tests, I want to make sure that all the speakers are there, especially me, and that my description is what I said it should be, so Bobby doesn't change it under my feet or something. So let's look at how we can test this with some code. Over here on the left, I have a page object that I put together for the home page. And I have some element selectors for the logo and the Twitter link and the rules for like the code of conduct. And, oh yeah, sorry. How's that? Is the dark okay to read? I totally forgot to check this before I put it up. So I also added to the page object what I expect the Twitter link to be, because that's kind of a property of the page. And then I added some helper functions for like getting the website, getting the dimensions of the image, the logo, and then a fun one for calculating angles. Since I said in this talk we were going to check angles, I felt it appropriate that we like actually check the angles, which was interesting to go back to like 7th grade, 8th grade geometry stuff. But it's just calculating arctangent and then converting from radians to degrees. So, and let's look at our spec to see how we actually use this. So we have the homepage page object that we require, just like Node we usually do. And then before each test, we're saying that it's not an Angular site. And before each of the homepage tests, we're newing up a homepage page object and getting the homepage. So we're starting from a fresh load of midwestjs.com. So we write a test to describe the logo. And I say it should have a cow on it. Basically what I meant by that was that the logo was present. So my element selector over here is detailing what the logo should be, and I can just have a really simple test that says, is it present? I also did a test to say that it should be a 400 by 400 square and thus have 45-degree angles through the middle, because that's what squares are. And then I could check angles, like I said I would. So we get the cheese size. This is one of the things that you'll run into with Protractor tests. Everything returns a promise from the Protractor API. And this gets abstracted away from you a little bit when you have simple things where you're not doing anything with the results besides expecting them. Because Protractor is actually queuing up all of the things that return promises, doing analysis on your code, and waiting to execute one until the next one is done, the previous one is done. And it looks for that in the expect function so that it actually waits for this is present promise to resolve before it runs this expectation. So in simple examples, you'll see you might not see a lot of actual handling of the promises that are getting returned. But when you want to start to do something with the resolution of that promise, like for example, I want the height and width of this web element's size so I can run tests on it. And I can't expect on that stuff without resolving that promise first. So I have to wrap my expectations in a then block. Does that make sense to everyone? There's a great resource on this. I have a link to it later in the slide, but it explains kind of how this queue that Protractor puts together throws up. And I say that the Twitter button should link to the Twitter link target, and that it should have a code of conduct, because that's important. So let's see this actually run. I guess I talked about there needing to be a configuration file. So I have this configuration file with a couple of suites in it. This is an alternative to writing the specs portion. You can actually specify like different sets of things you want. So in one config here, I was able to add the Midwest.js specs to a Midwest.js suite, and the Prisotron, which we're going to get to in a minute, to another suite. There's some stuff in here for my CI environment that we'll get to in a second. So let's just see this run. So if I run Protractor with that configuration file, and I specify the suite that I just want to run Midwest.js, let's see what this does. So it starts up Selenium. I actually have it running Selenium in the same process as the Protractor stuff. And it's booting up. It went through the homepage test really fast because there weren't very many of them. And now it's running speaker tests, where it asserts there's a certain number of speakers, and that when you click on the link in next to my name, that it pops that up. And there you go. Everything passed. Now, I don't usually trust tests that I wrote the test correctly until I see it fail first. And I did this on my own time, but I'll show you guys just to give you a demonstration of the fact that it really does fail when you don't do it right. If we decided to assert instead that the code of conduct wasn't there, like if someone took that away from the website, we get an F as the tests are running. So you can kind of see as the tests are running that there will be a failure, and by the time the suite finishes, we'll get to see what the failure was. And I could be writing my expects better with a message that would give a better failure message than what's about to happen. But I neglected to do that because I didn't know about that feature of expectations until recently. So expected true to be false on homepage 41, right here. So hopefully that was a reasonably good demonstration of testing a site without Angular. Let's talk about using Protractor to test Angular apps, which is what the tool was built to do. It was all the functions in there, like the queue of promises and stuff, that's set up in such a way that it makes sure that testing Angular sites looks easy. Looks like those specs where they don't even show the fact that they're returning promises at all. This is kind of, what the tool is meant to do. It's not to say that you can't test non-Angular apps, but it is better at this. When you're testing an Angular app, your tests, I think, become more robust because you're not using those jQuery selectors where, for example, with the Midwest.js site, I don't have any control over what the IDs are in there or anything like that, and I have to write potentially complex selectors to figure out which thing is the logo or which thing is the Twitter link. And with Angular, you can bind to models or repeaters or template bindings, which generally speaking, you usually have control over, and therefore, you are much more aware of when you're going to break that. We also have cool projects, like one called Gulp Protractor QA that was written by that same guy with the awesome slides, Ramon Victor. That project will actually do static analysis on the templates you tell it and check all of your element selectors to make sure that they still exist in your templates. So like for your own project, You can have that hooked into your gulp tasks. And without even having to run the tests in a much faster feedback loop, learn if you accidentally broke one of your Protractor element selectors. I have links to that in the resources slide. You can also mock out HTTP calls. This is that caveat that I mentioned earlier. You can do end-to-end tests where you test some integrations, but be choosy about which ones. Like, for example, if you have some integration with a third party that goes down all the time or doesn't have a good test environment that you can play against. Note that this is kind of losing our end-to-end what the user will see definition. It's cheating a little bit. Users are going to see the real site with the real integration. So I would be choosy about when you want to do this and save it for those kind of instances where like you have a third-party integration that is just really unstable but has a more stable production version. So let's see this in action with a little project we use for the meetup group called the Amazing Prizatron. If it loads up, it's just on a little Heroku gear or whatever they call it. So it takes a little while, but this is a nifty little thing that one of our members wrote that allows us to hook into the meetup.com API and fetch the list of RSVPs for any given meetup. So if I put in my API key, which I'm keeping a secret, and an event ID, this one happens to be for a dodgeball pickup game that I went to in July when I started writing these slides. And I go and import the names. I get the names of the people that went to the meetup. And I can pick a winner, like me. Yes! I promise it's not rigged. Pretty sure it's not rigged. So what would testing this thing look like? Well, what are the important bits of this? We want to make sure that it has places to put in the API key and the event ID, that it can go and grab things from meetup.com. If the meetup.com API were unstable, we would potentially want to mock that out. And then we want to make sure that we can pick winners. And theoretically, we would want to test that the winners are random. But I read a lot about testing randomness, and the general consensus is even in unit tests, you really have to isolate what the random function is and then mock that out hardcore. So for an end-to-end test, there's not really a good way to test randomness. So, and then the last thing I wanted to make sure was that the reset button worked so that we could start testing things again. So let's take a look at what the code looked like to test this. We'll get the page object over there. Oops. And the spec over here. OK, so for the page object, I have the two input boxes for the event ID and the API key. And notice that, I mean, this looks way cleaner than some of my selectors for any given non-Angular website. I don't have to go traversing the DOM to try and find an element if there's no handy ID on it or something. I know what I programmed this particular thing to be. It's an API.key. Wow, that really makes sense. Buttons, we're using this bi-partial button text, which I'm going to talk about more in a bit. But essentially, the bi-button text selector is very choosy. So you have to be careful when you're using it. Bindings, so things where we're binding to show the length of the either RSVP queue or the selected winners queue. The repeaters, and then some utility functions, like that same get one. I found that to be a nice pattern. You can also do some of this setup in your configuration file, but I liked having it here. And a function to do the importing of data just for shortcut's sake. I didn't want to type out, send the keys to the API and the event, and then click the import button. Having a nice little function for doing that helped clean up my tests a bit. So my spec is using a couple of different files, not just the page object. So for something like this, there's sensitive information, my API key. I want to keep that a secret, and I don't want to share it with other people and have them, abuse the crap out of the Meetup API masquerading as me. So I keep these in a secrets file and have Git actually ignore updates to it. So I checked the file in so that everyone knows that it's there with just a bunch of crap data. And then I told Git to ignore it and added the secrets myself. Kent was telling me at lunch about some cool tools I could use to hook Git hooks up to this so that people who pull this down could not have to remember to do that. But right now I just have a big thing in the README that says, please remember to not check in your secret keys. And then a backend mock. I didn't actually get this to work. From what I could find about doing the backend mocking, it's actually a little bit difficult, and you may or may not have to add something to your running application to give it hooks to allow your tests to override the HTTP backend. If someone knows how to do this better, I would love to hear about it. But the research I did not turn up a lot about kind of how to take someone else's arbitrary site and mock out the HTTP backend of it. Because I don't actually own that Prisotron. One of our members wrote it and has the Heroku stuff for it. So we knew up our page object and our secrets, and then we get, just like the other test. I threw this test in here since I wasn't using that Gulp Protractor plugin to just have a sanity check that all of my element selectors were good. So everything that I expect to be on the page when it loads is there, and that for some of the things like the selected and remaining badge, those should start out at 0. So I have this expected default badge text to just be string 0 up here. Testing the input boxes to make sure that when you click import, some stuff gets in there. This was the commented out code for the mock backend. So if people want to see as far as I got, feel free to check it out. And selecting the winners. So this is another one of those instances where I wanted to iterate down and click the import or the select a winner as many times as there were RSVPs to assert that it was exhaustive. So I need to know how many people ended up coming back from the API to do that well, and thus wrap that in a then block, make sure the promise is resolved so I can operate on the value. So we're just iterating for all the remaining members to click and expect that the winners went up and the remaining list went down until the end, where the selecting winner button should no longer be enabled because there's no more winners left to pick. You picked everybody as a winner. And then testing the reset button, expecting that when you click a couple times and then click reset, everything gets set back to default. And be very careful about going down the path of testing randomness. So let's run these tests. We're just running Protractor and passing a different suite this time for Prisotron. And like Venkat, I like to see as little on the screen as possible to make sure I'm just looking at what I'm doing right now. So here you see it loading up the browser, getting the page, asserting that all the things are on there, getting the browser again, running the next test. This is the one where it selects all the winners. This is the reset test. Boom, done. So it's not like it takes an insane amount of time if you're careful about what you're testing. 15 seconds is not forever. It seems like forever when you're coding, and if your unit tests ran that slow, you'd probably pull your hair out or just like end up getting up to get coffee half the time and forgetting about what you were doing. If you're like me, I can be absent-minded at times. But 15 seconds, like I can wait that long to see that my whole website is doing what I thought it should. That's really useful and powerful. So let's go back over to our slides. So some of the gotchas that come with doing this stuff. We've touched on them a little bit already, but just to be explicit. The promises. You have to keep track of when you actually need some value resolved and want to operate on it in something besides the middle of an expectation. That's the only place where Protractor is making sure that things are resolved before you expect them. There's a great page on the Protractor documentation on GitHub that explains kind of how this control flow works. This is the link to check that out. Console errors. So you can have major failures with your website, and if you don't have a test to cover them, it may not be obvious. Your test may inadvertently cover a major failure, like the page not loading or something like that. But you know, your console may have a lot of great information about why something didn't fail, and you don't want it to have a bunch of errors in it. And it would be great if you could test that. Well, if you go to Egghead and watch this like 3-minute video that describes how to do it, it's actually pretty simple. You just add an after each, and you can get a hook into the browser's logs to assert things about like the length. Here again, you can see adding the then block because they actually want that browser log resolved before they make any assertions about it. Button text. By button text means exactly by that button text, like the exact inner HTML of it. So that includes like if you have a span for like a silly font icon for your button or something like that. You have to include all of that in your by button text in order to target it exactly. So what I ended up doing is using the much less strict partial button text so that things like my import button with a little arrow in it, I don't have to copy all that HTML into the selector. You know, depending on what's on your page and how similar some buttons are, you could get into trouble doing this. You can also use by CSS and target the ngClick attribute. I would recommend picking one strategy and sticking to it, do one consistently or the other. It's kind of a question of whose perspective you want to write the test from. If the selector is from the user's perspective, they see the button text. That's what they identify that button as. This ngClick thing is nothing a regular user knows about. But from the programmer's perspective, which is you writing the test, you're the only one that's going to see the guts of the test. And if it makes more sense to you to identify that thing by its click handler, maybe that's more useful. What happens if you get stuck? This happened to me a lot. There are some great debugging tips on the Protractor GitHub page. And one of the really nifty ones is to do this -- element explorer. From this place, you can execute all of the Protractor API in an interactive mode. It's not like insanely helpful where it's like highlighting things and big flashing lights on the page if you try to do the selector for it. So you can, you know, do simple stuff like just get text on it, and it'll fail if your element selector is bad, and you can see what the text is and run the other Protractor API calls on it, whatever you want to do. But that can be really helpful if you're just like, why is this thing not on the page? That happened for me for the Prizatron app a little bit, because the repeaters don't actually work as selectors until there's something in them. So I have to wait until after I import all of my data to use my repeat selectors. So we talked about continuous integration and continuous delivery a little bit at the beginning of the talk. And this would be something great to know how to do, right? Like, this is all great that I can run it on my development machine and it runs reasonably fast. But how do I hook this up so it's automated? That's the real value in it, right? Well, I'd recommend asking yourself a little bit about what you control on that CI environment. You know, if it's your own box and you are maintaining that box's uptime and stuff like that, you have more control over it. You can install Protractor globally, and then you can speed up your tests because you don't have to install Protractor all the time. But if you don't have that level of control, if you're using a third-party service like I did for this project, you can install Protractor locally and run all the commands on it from where it installs locally. It makes your tests run a little bit slower because you have to install Protractor, which takes time, but it's not the end of the world. It helps to have reports. So if you can have coverage reports or nicer looking things that say what passed and what failed, or screenshots, I found this nifty little thing to take a screenshot every time it fails and export a little directory of all the screenshots. So when I had failures, I could go and look and see, like, what did the browser look like when that test failed? Like, why did this test fail? And have a visual aid for that. That's really cool. So let's take a look at this to see how you might get it done. Per recommendation from Kent's Medium blog, I decided I would try out Snap, which is, oh, that's not what I wanted to do. Oh well. Which is made by a company called ThoughtWorks. They do a lot of cool stuff in the development space. But this is free for public repos, so I can just hook this up to my repo and have it run exactly the same things I'm running on my, oh, I'm incognito, so that's why I can't show. Yeah. Let me get another browser window open so that you guys can see that. Sorry for the hiccup. I practiced this not in incognito mode and then totally forgot, which was silly of me in hindsight. I didn't want any notifications to show while I was doing the presentation, though. I turned them off, but I didn't trust it. So you have these different stages in Snap CI, which might be different from what you're used to configuring. I do a lot of Jenkins configuration at work. And this was actually way more slick, but it was a little bit of a different way of thinking about it. Stage 1 is running the Midwest tests, and Stage 2 is running the Prisotron tests. And we can go in and look at the config for this. And it's actually quite simple. Once I knew what I was doing, it didn't take very long to set up. I'm just npm installing, where I have Protractor saved to my package JSON. I'm running this WebDriver Manager update, which goes and downloads the Selenium runner. npm install doesn't do that by default because it's like 20 or 30 megs or something. So you don't just want to do that unless you're actually going to run the tests. And then running the tests with Protractor. And I added this artifacts thing to make sure the screenshots get persisted after the test runs. And for the Prisotron, these tests were failing on Snap for the longest time. I couldn't figure out why. And I felt like an idiot when I figured it out because I hadn't uploaded the secrets file that I had locally with the actual API keys, which is why that was failing. It felt pretty obvious once I figured it out, but it was hard to figure out before that. But you can upload it securely to Snap, and I don't have to check this in now. I can keep it secret. It's here, and it's on my machine, and it's nowhere else. And if we go back out to the main page, we can see it's been running for like 10 days or so, totally fine, up until that point where I had realized I needed to upload the secrets. And just for fun, there's a spot I can run this again. And it'll run again. It takes a little bit of time, like I said, because it has to npm install, and then it has to run the tests like it does on my machine. But it's actually not that much slower to run the tests out here. I was surprised. I have a beefy developer machine. It's a little old, but it's got 16 gigs of RAM. So I figured that the Snap CI environment would run things slower, but it actually just takes most of its time doing the npm install and the WebDriver update. So this should finish in about 10 more seconds, and then the other one should take about the same amount of time just for doing the downloads. But like, this is really slick, and it emails me when I committed something that broke. It runs on every commit. Helped me out a lot. And like I said, it took maybe like an hour to get set up. It's taking a little bit longer. There we go. So let's put that over here and then get back to our slides. So while we wait for that to finish, I'll talk about some other tools that are using Protractor or are helpful to use if you're using Protractor. There they go, they passed. There's two in particular I want to talk about. One is Sauce Labs. They're a company that will let you run all kinds of different browsers by calling their API and sending them your Selenium-based tests. I don't know if they take other tests frameworks actually, but it's a really cool concept that I would love to be using at work because we're maintaining our own IE8 VMs to run IE8 browser testing, and that's a serious pain. Not to mention doing like mobile testing for all different kinds of mobile browsers. Sauce has all of that kind of stuff, and I don't know, to me that sounds like a huge win. It's paid after some amount, I don't know exactly, but I know a lot of people in the Protractor space use it. There's a lot of examples out there that reference it, and it seems like a great thing to have. The other one I wanted to talk about is BenchPress. This is a tool that's coming up built on top of Protractor for doing like macro level benchmarks on your site. So not little micro, like how fast does this widget re-render if I render it a bajillion times with 1,000 things in it, but overall, like my page load, does things show up in a reasonable amount of time? How long does it take if I add 100 things versus 1,000 things? And you know, a tool like that, if you added it to your CI system and just did a little bit of code to measure, you know, I don't want my site to run any more than 2% slower from release to release, or I don't want the initial page load to go over 1 second or 2 seconds or whatever is acceptable for your users. Hooking something like this up could be insanely useful for something like that. We strived to do this at my previous job and never quite got there, and I would have loved to have something like that to ensure either things weren't getting worse or to measure how much better things got. Like we did a big rewrite of our mobile application, and I would have loved to see like how much faster the page loaded with some kind of automated tooling, not just from our own kind of ad hoc performance tests. I have a confession to make about this talk, and hopefully it doesn't make anyone mad. I've only been doing Protractor for 2 months. So I signed up to do this talk, and I had not written any Protractor tests at all. I'm going to get my notes over here because they crashed for some reason. I love Will Smith. So hopefully you guys weren't expecting like a high level of Protractor expertise. That's not me. Some of you might be thinking, wow, Will, you must be crazy. Why would you sign up to do that? That sounds like a terrible idea. What was your angle thinking you would do that talk? Well, I was daring myself to learn. I wanted to learn this, and I thought it would be a great way to make sure I learned it, to be accountable. And I wanted to prove to myself and to the community that I could learn things I'm interested in with my spare time, that end-to-end testing can provide a ton of value for you, even in ways you might not think, that it doesn't have to be as hard as I felt like it's been in the past, and that you don't have to be an expert to give a conference talk. I know this is kind of off topic, but you guys are my captive audience, so bear with me for a little 2-second rant here. No one should have to be afraid of participating in this community and sharing what they learn. We should be welcoming as web developers, but harassment happens, and that sucks. So I have a lot of privilege as a white man who got a lot of things easier than a lot of people. I got really great training from a lot of smart people early on in my career, but not everyone gets that, and we have to make sure that we're proactively seeking ways to include people, because We have a lot to learn from diverse perspectives. It'll help us make better software, and it'll just help us grow as people. So if you're thinking, wow, that sounds really hippy-dippy, Will, I don't actually know how to do that, though, because it's a super hard problem. And you're right, it's not a problem any one person can solve. But there are two little things you could do that I would really encourage people to try out. Speak up and amplify other people's voices. This is a hard problem, but we can solve it little bits at a time by saying something when something is inappropriate, even if it doesn't personally make you uncomfortable. If you can empathize enough to know that that's going to make someone else uncomfortable, say that it makes you uncomfortable. And when someone does something cool that's different from you, share it. Even if they're not different, just share all the cool things and help build each other up. I think that will make this place a lot cooler to be. I hope this provided value for some of you. Thank you a lot for listening. I made sure to include a cat picture because I was told I had to. This is a link to the resources that I found useful. Pretty much all the links I read while I was putting this talk together. And if you'd like to be 10 years old like me and collect stickers for your laptop, I have stickers to give away to anyone who wants to ask questions. Thanks. But for real, I have stickers, so who wants to ask a question? Yeah, I didn't include it in my Twitter link, but you can test the URL changing. So anytime you click on something and you want to assert that the route changed, you can just check the browser URL. I didn't see anything in the Protractor docs for like asserting it by route and not by like URL string, but I assume it'd be possible to write a plugin to do something like that. And even if you can't, you can assert things about the URL specifically. Mm-hmm. You get a sticker. Any other questions? Yeah, they're Angular Amend stickers, so they're really well done. Our designer at my former company, Virtuel, put them together for me, and I thought they turned out really nice. I'm not. No, I work for Optum now. Any other questions? Cool. Well, thanks.